Imagine for a moment that you're trying to unlock a very specific door in this massive office building.
Yeah.
But instead of going to the front desk and just asking for a key, you decide to use, well, you use a highly volatile explosive device.
Oh, yeah, that's a choice.
Right. You just set it off in the hallway. And sure, you might actually blow the door off its hinges and get exactly what you wanted.
Yeah. Or you blow up the entire house just to find a single doorknob.
Exactly. But that sheer, brute force chaos is basically how most software programs read and extract your messy data today. They just blast through the text, hoping they hit the right target.
It really is the ultimate quick and dirty method. I mean, when we face a massive chaotic document like a giant log of transactions or a messy manuscript, we just want to hack our way through the brush.
Yeah, just get to the treasure as fast as possible.
Right. We expect a simple command to do all the heavy lifting without really thinking about the structural damage it might be causing behind the scenes.
Welcome to the deep dive. Today we have a really special mission for you. We're going straight into the fascinating world of text parsing, and we're looking at it entirely through the eyes of a veteran coder.
It's a really great perspective to have.
It really is. We are going to unpack how replacing those duct tape, explosive coding habits with highly structured logic can completely alter how we process information.
And honestly, it changes how we approach messy problems in our everyday lives, too.
Our guide for this is a March 2026 blog post titled Notes on Haskell Programming, Part 83, Initial Parsing with Megaparsec.
Yeah, and it's written by a developer named Ang, who probably describes himself as an old software plumber.
I love that term.
Me too. And that perspective is exactly why this is worth our time. We aren't looking at a tutorial from someone fresh out of a coding boot camp who thinks every new tool is like a magic wand.
Right. He's been around the block.
Exactly. He's spent decades in the trenches of software development. He has seen fads come and go, so he is laser focused on what actually works reliably in the long run.
Okay, let's unpack this core conflict Ang was facing, because when you look at the source of his frustration, you realize it's something anyone who's wrestled with a messy spreadsheet will instantly get.
Oh, absolutely.
So Ang was building a Python pet project called txt2book. The goal was simple: read a raw text file, pull out the chapter title, structure the content, and spit out an ebook.
Sounds straightforward enough.
Right. And to do this, he used something called regex, which is short for regular expressions. It's basically the industry standard for pattern matching.
It's everywhere.
But Ang admits that while finding the pattern was easy, the logic he had to build around the regex turned into a total nightmare. He actually calls it alphabet soup.
And alphabet soup is just the perfect visual for it.
It really is.
I mean, if you've never looked at a complex regular expression, it genuinely looks like someone just smashed their hands on a keyboard.
Lots of slashes and brackets.
Yeah, a dense landscape of slashes, question marks, asterisks. But the real problem isn't just that it's ugly. The problem is the underlying mechanism. Well, regex operates almost entirely on blind positioning. You're basically telling the computer, hey, look for a word that looks like a number and grab the chunk of text that comes exactly 2 spaces after it.
Right. He specifically mentions the danger of relying on what regex calls captured group 1 or group 2.
Exactly. Because let's say the format of your document changes just slightly. Say someone accidentally hits the space bar twice instead of once before a chapter title.
Oh, then the whole thing breaks.
Yep. The regex doesn't actually understand what a chapter title is. It only knows the position. So instead of grabbing your title, Group 2 might suddenly just capture a blank space or, the first letter of a paragraph.
So it blindly grabs garbage data, assumes it did a great job, and just passes that garbage deeper into your program.
It is the absolute definition of brittle architecture.
So instead of just complaining about it, what's fascinating here is the specific philosophical shift Ang chose for his rewrite.
It's a huge pivot.
Yeah, he decided to rewrite the entire program in a language called Haskell, calling the new version XS2book. And to parse the text, he completely abandoned regex.
He went in a totally different direction.
He did. Instead, he used a Haskell library called megaparsec, which is what's known as a parser combinator.
This is a massive leap. It's moving from a chaotic catch-all approach to a meticulously structured philosophy.
Right.
Because a parser combinator doesn't try to read the whole document in one massive, confusing rule. Instead, it uses tiny, hyperspecific modular functions.
Think of regex like a giant, messy master key. You file down all these weird, jagged teeth on it, and it tries to force open every door in the hallway at the exact same time.
Right, and sometimes it works.
But often, the lock jams, you get a generic no match error, and you have absolutely no idea which tooth on the key was the actual problem.
Which is incredibly frustrating.
Exactly. Aang realized he didn't want a master key anymore. He wanted a very neat keyring with a set of specific, clearly labeled individual keys.
That distinction is crucial. When a parser combinator fails, it doesn't just give you a generic failure. It tells you exactly which tiny function failed and where.
So it's much more specific.
It tells you, I was expecting a number on line 42, character 5, but I found a letter instead. The error messages are incredibly precise.
But wait, let me push back on this for a second, just on behalf of the listener.
Sure.
Let's put ourselves in the shoes of someone whose primary goal is just getting the job done. Regex is ubiquitous, right? Built into almost every language.
Yeah, it's everywhere.
If it gets the job done quickly, even if it's a bit ugly, isn't throwing it out to write dozens of tiny modular functions just bloating your code base? Like, does it really save time?
It's a classic trade-off between writing speed and maintenance speed.
Huh.
Regex is notoriously known in the industry as a write-only language.
Write only.
Yeah, meaning it's incredibly fast to write in the moment. But if you step away for 6 months and try to read that alphabet soup again, you will have absolutely no idea what it does. You literally have to reverse engineer your own brain.
Oh, that sounds awful.
It is. Aang explicitly addresses this by pointing out how a library like megaparsec enforces upfront organization.
Right, he mentions his updated Haskell coding style, specifically how he handles his imports.
Yes, he explicitly imports modules now. That means at the very top of his code file, he spells out exactly where every single tool and function is coming from.
So no more guessing.
None.
Yeah.
He doesn't just import a massive library and hope the tools are in there. He lists them by name. He even notes that sometimes this causes name conflicts, forcing him to use a command called hiding to suppress overlapping names.
But he embraces that friction.
Exactly. That upfront organization is the foundation of his house. It completely prevents those massive headaches down the line where you're just guessing where a tool came from.
It slows you down in the beginning so you can run infinitely faster later.
Exactly.
I want to look closely at how these tiny modular functions actually operate, because Aang doesn't just talk theory. He shares his working code from a file called parser.hs.
Right. Specifically the section that handles parsing the chapter headings.
And instead of reading the syntax out loud, because that's always a bit dry, let's talk about the behavior here, because the mechanism is brilliant. It works like an assembly line.
An assembly line is the perfect way to visualize it. In a parser combinator, a piece of text comes down a conveyor belt.
Good.
A tiny function takes the text, examines the very first part of it, consumes exactly what it was programmed to find, and then, this is the magic part, it passes the remaining unread text down the belt to the next function.
And we see this assembly line in action with a concept I'll call intentional ignoring. Aang wants to parse a chapter heading, right?
Right.
In a specific text, chapter numbers often start with a literal Chinese character, dai, which acts like a prefix. Think of it like the word number in number 1.
Yes.
Aang needs to know it's there, but he doesn't actually want that word in his final data. He just wants the digit.
So in lines 13 and 15 of his code, he uses a specific command with an underscore to look for that exact character.
The underscore is the key there.
Yeah. The function confirms it exists, chops it off the front of the text, throws it directly into the trash, and passes the rest of the text down the line. He's stripping out the formatting metadata on the fly, completely by design.
Meanwhile, on line 14, he captures the actual index number into a variable called I.
Exactly.
But for the chapter title itself, and here's where it gets really interesting, Aang uses 2 completely different kinds of functions. He uses one called take while 1p for the number.
Okay.
And later, on line 16, to grab the actual title of the chapter, he uses a function called take while p. Notice the missing one there.
That single digit fundamentally changes the behavior of the function.
Right. Think of the function with the 1 like a massively strict bouncer at a nightclub. The 1 means it demands at least 1 character of substance before it lets you through.
It absolutely refuses to accept an empty value.
Exactly. Aang explains that this ensures the parser doesn't accidentally capture a phantom chapter. If the text just says chapter with a blank space and no number, the bouncer steps in and says, no, this is invalid data, shut it down.
It guarantees the data has substance. But the chapter title itself is optional. Sometimes a book just says chapter 1 and leaves it at that.
Right.
So for the title, Aang uses the more relaxed function, the one without the 1. It grabs everything until it hits a new line character, meaning the end of the line. But if it grabs absolutely nothing, It doesn't panic.
It just says, that's perfectly fine. Optional data is optional.
Exactly.
And then line 17 just cleanly glues the strictly verified number and the optional title together. You're entirely eliminating the guesswork. The program isn't skimming the text. It is reading it with intense purpose.
And this brings us to a foundational concept in this type of programming type safety. Because every single step on this assembly line has strict, well-defined rules, the data coming out the other end is guaranteed to be exactly the type of information you expect.
No surprises.
None. If you want a number, you get a number. You aren't relying on positional hope like regex does. You've built a structural reality check.
Okay, so we've looked at the tiny functions, the workers on the assembly line. Let's look at the factory floor itself.
The engine room.
Yeah, how do these elements get packaged and actually executed? Because Ang dives into some pretty dense architectural terminology here regarding how the parser is built.
He does.
He talks about constructing the parsec type using 3 specific arguments, an error component, E, a stream type is, and a result type A.
Yes, the custom error component dictates exactly how the system handles and reports mistakes. The stream type defines the nature of the raw material flowing in. Is it text? Is it binary data?
Right.
And the result type defines the exact shape of the finished product coming out.
But here's where it gets highly abstract, and I want to make sure we're translating this clearly for you. Ang points out that his code explicitly leaves that final argument completely blank.
The hanging A.
Yes. He calls it a partially applied type. How does a program even run if it's missing a core piece of its own definition?
It is a brilliantly flexible feature of functional programming. Ang defines his chapter parser on line 11 as returning a parser text, which expands into parsec void text.
Okay, but what does that mean practically?
Think of it like a Mad Lib sentence. If I hand you a piece of paper that says, "The quick brown fox jumps over the blank," that is a partially applied sentence. The structure is perfectly defined, the grammar is sound, but the final meaning is left open. By leaving that final result type undefined, he's building a highly reusable machine.
So it's rigid where it absolutely needs to be for safety, but infinitely flexible where it matters for utility.
Exactly. He's setting up the error handling and streams, but letting the specific function decide the final output later.
We actually see that safety come into play in the final part of his script, the runner. This is the code that feeds the raw document into our assembly line.
First, he has to prepare the fuel.
Right. On line 22, he uses a command called pack input to convert standard raw text strings into a highly optimized format that the megaparsec library needs.
And then, to actually start the engine, he uses a command called parse maybe.
And parse maybe is arguably the most elegant safeguard in the entire program.
Absolutely. In traditional brute force parsing, if a program hits a character it doesn't understand, it will often panic and crash the entire application. It throws a fatal exception.
The explosive device blows up the house.
Precisely. But parse, maybe, forces the program to handle reality gracefully. It dictates that the outcome will strictly be one of two things. Either it returns a package of data marked success, which is just titles, or it returns a mathematically defined concept of nothing.
No crashes, no silent failures where it pretends it worked, just a polite structural, I found it or I didn't.
And because it returns nothing, instead of crashing, it forces Ang to explicitly write code handling what the application should do when it fails. It removes unpredictable behavior entirely.
Okay, so we have these tiny, precise workers grabbing characters and an incredibly safe engine running them. But how does it know to keep going?
Right, for the whole book.
Yeah, we aren't just parsing one chapter heading. How do you tell the assembly line to loop without creating a massive, tangled mess of code? Ang calls this the actual combinator of the setup.
The master glue.
Yes, the master glue. It's a function he points out at the end called sependby.
Which translates to separated and ended by.
Exactly. He explains that this single, remarkably clean line of code tells the parser to look for a chapter followed by some kind of separator like a space or a blank line, and just repeat that process until the end.
And the true beauty of it is that it allows the separator to exist between the items or hanging at the very end of the file without throwing an error.
It handles the messy reality of how human beings actually format text documents.
It really does. And if we connect this to the bigger picture of Ang's life, it perfectly mirrors his mindset as a thinker.
I'm so glad you brought that up.
This logic taking small, perfectly defined units of truth and linking them together with clear boundaries to manage a massive system. It isn't just how he writes code. It's how he engages with the world.
If you look at Ang's website, it's a journey. It is truly mind-blowing. He has thousands of posts. You look at his archives, and they go all the way back to July 2011.
Over a decade of consistent documentation.
Month after month, year after year, everything is meticulously categorized. He isn't just writing about Haskell programming.
Not even close. It is the digital footprint of a mind deeply committed to structured knowledge.
You look at his projects list, and it is this beautifully eclectic tapestry. He writes about free, Libre, and open source software. He's diving deep into Elixir, Go, and Rust.
All highly technical stuff.
But right next to those technical deep dives, he has notes on fish keeping. He maintains incredibly detailed betta spawn logs tracking the breeding of his fish.
That's amazing.
He has notes on gardening, tracking exactly how to propagate crown of thorns plants, notes on dieting. It is a masterclass in continuous, deliberate learning.
Notice his naming convention, too. Notes on Tabor. It implies ongoing discovery. Every single post, whether it's part 83 of Haskell Programming or part 800 of gardening, is a tiny, self-contained, verified piece of knowledge.
It's structural integrity applied to curiosity. He even lists the organizations he supports, the EFF, the Free Software Foundation, Wikipedia.
Organizations dedicated to open, structured information.
Exactly. You really get the profound sense that for Ang, writing clean, modular code isn't just a professional requirement, it is a philosophy for interacting with information.
When you step back from the code and look at this entire ecosystem, you have to ask yourself why this matters. Why does a deep dive into an old software plumber's blog matter to someone who might never touch a parser combinator in their life?
So what does this all mean for the listener?
Well, it's fundamentally about how we choose to handle complexity. It's about actively deciding to walk away from the alphabet soup.
Right. Breaking down messy, complex problems into small, understandable, and safe building blocks.
Exactly. Looking at how Ang approaches his data, this raises an important question about our own intellectual habits. When we're faced with an overwhelming amount of information, a complex issue, or even just our daily digital clutter, are we relying on brittle, complicated workarounds?
Are we using the messy master key, brute forcing our way to a quick conclusion, knowing our understanding might shatter the second a new piece of data is introduced?
Or are we taking the time, even if it feels painfully slow at first, to build a reliable modular foundation? Ang proved that the quick and dirty regex method is an illusion.
It just shifts the massive burden of complexity onto your future self.
Yes, by intentionally slowing down, he created a system that doesn't panic when it encounters the unknown. It just politely returns nothing and moves on.
He engineered peace of mind. And I want to leave you with a thought to ponder on exactly that. We live in an era defined by information chaos. It is a constant stream of messy text.
Very true.
Ang has spent 15 years documenting his deep dives into everything from AI to the precise needs of betta fish, maintaining this incredible modular discipline.
The huge commitment.
If applying strict combinator logic allows someone to reliably transform a chaotic data file into a perfectly structured book, what messy text in your own life could benefit from being broken down into defined combinators?
Whether it's your schedule, your hobbies, or your goals.
Exactly. What would happen if, instead of trying to understand a massive issue all at once, you built your understanding the way Ang builds a parser verifying one tiny truth at a time and carefully linking those truths together until the bigger picture slowly reveals itself?
Sometimes the absolute best way to tackle a massive problem is just to calmly identify the very first piece of truth, process it, and pass the rest down the line.
No explosive devices and no alphabet soup required. Thanks for joining us on this deep dive. We'll catch you next time.